your math and science ones if we're closer together?
All right, so on page 267, this is very similar to a problem we finished yesterday. It has the same steps. You're given a rational function at the top. Ultimately, we're going to find all these pieces of information, and at the bottom, we're going to be able to put it together to create the graph. So since you have an example from yesterday's notes, what I'd like to start out doing, you can work in your partners that you're sitting with, or if you want to move, if you don't have a partner, that's fine too. But I'd like you to go ahead and try to work through this problem, and then we'll go over any questions you have, and then we'll put some answers up on the board. So go ahead and start on this problem. You can look at yesterday's to help you with it. You just want to help her with today's notes and then get caught up after that. It's a lot of the ideas she should have from the last week still, because it's a lot of the same ideas we were just building upon it, actually graphing now. So. As you're working through, make sure you check your answers up on the board. If you have any questions, raise your hand. We'll go over a section that you have trouble with. In the first box, I showed the completely factored form and the reduced form, because that will be helpful later in the problem. Plug it back in here, you're going to get 0 over 0, so you plug it into the simplified version. Make sure when you do get to the bottom graphing part, go ahead and try to graph it. Make sure you have at least 3 points for each part. should be numerator here, not denominator. Since there's not a remaining factor in the numerator, the graph does not have a 0. It should be numerator, not denominator. Remember, zeros or x-intercepts are at the top. Numerator. Make sure with your domain and range, domain are your x values, range your y values. Question, Marie, or stretch? Question or stretch? Anybody have any questions so far? I know some of you are finished. We'll just wait a minute or so till everybody else finishes, and then we'll move on. Just double check your answers, make sure you have everything correct. Make sure when you draw your graph, wherever your hole is, make sure you don't draw the line through the hole. Make sure you leave it open. Make sure you don't cross your asymptotes anywhere. I think everybody, if not finished, is on the last step. Any questions on this problem so far? Any confusions? Anything that doesn't make sense? Getting a little easier. Alright, so if you're still finishing up the last step, that's okay. Keep finishing it. I'll keep this answer up here for a few moments. But if you're finished, if you want to go ahead to the back, there's two problems on the back. So they give you a graph and they give you the rational function. And if you read the directions for both of them, they want you to find the asymptotes of the graph and then draw them on the graph. So you need to determine where the vertical asymptote is. So if you don't remember how to find it, look back at your notes, figure out how to find the vertical asymptote. And then you need to either find the horizontal or the slant, whichever one that is. So determine whether it's a horizontal or slant, and then actually calculate where that horizontal or slant asymptote is. After you find both of them, draw them on the graph. So if you want to go ahead and work on those two problems, that's what both of those want you to find, both asymptotes. Since they give you standard form for both of those, what would be the best thing to do first for both of them? Factor them, yes. Factor them. Do you have the answers that she gives? Remember when finding your slant asymptote, it'll be of the form like y equals mx plus b, because there's a slope and a y-intercept. Question, Emily? Let's see. Well, if you think about it, the reason you would need to factor the top is to see if it cancels with the bottom. So is the top going to factor at all to cancel with the bottom if you try to factor it? No, so that's the reason you would try to factor to see if it cancels for a whole. But if nothing's going to cancel, you know the bottom's going to give you your vertical asymptote, so you don't have to worry about factoring it if it doesn't cancel it out.
And those last would be
Yes, after solving. if you were actually graphing that problem and you couldn't factor it, you would then use quadratic formula to find your zeros because you would need to figure out where it crosses. But if they already graphed it for you, so you don't have to find the zeros. We're just worried about the asymptotes here. I know we're all in a little bit of different spots, but make sure as you finish this up, you check your answers. Not trying to rush anybody, just want to know where you're at. Who's still working on these two problems? Sure. Okay. Again, if you have a question, you want me to come look at your paper, just raise your hand. I can come over and just talk to you. If you have a question on your work. So what would your slope be? Okay, what's your y-intercept? Yep. And then if you do look up here, it says cross rate at 0 because you have nothing there. Up 1 over 1, up 1 over 1, up 1 over 1.
Thank you.
Yep. couple minutes. When everybody finishes, we'll move on. So just hold tight till everyone's finished. All right, in about a minute or so, we'll get started on the next thing. We're actually going to start looking at the next section today. That'll be on page 273. We'll start going through that one together. So if you want to go ahead and get that page out, we'll be starting there in just a moment or so. All right, does anybody need a last look at the answers here? Any last questions before we move on? So on both of these, we had vertical and slant asymptotes. So the vertical you had to find by setting the bottom non-canceling terms equal to 0. And then for the slant, you had to do the synthetic division and divide by the coefficient on the bottom. And you found your equation for the slant asymptote. And both answers were provided there. Any questions before we move on? All right. Let's go ahead then. Page 273. So this next section, and I think this is our last section in this unit, is the analysis of rational functions. Analytical, graphical, and numerical approaches. So we've covered a lot of different topics with the rational functions. We've been able to find a lot of different information. So now we're able to graph, and if we have a graph, we're able to find equations. So for this problem, we're going to look at the graph and try to figure out some of the information to try to create the standard form, but we have to use the factored form to get to the standard form. So to start off, they said the graph of the rational function pictured to the right, such that h of negative 1.5 equals 0. So they're talking about right here. And there's a hole at 2, comma, negative 7/5. So that's your hole right there. State the domain and range. So simply they want you to look at your x and y values, where they do and do not exist for this function, and find the domain and range. Well, we're starting at negative infinity for domain. What value do we first have to stop at for domain, x values? Marie? Negative 3. Then we start at negative 3 and go to what x value now? Go ahead. 2. And then there's nothing else to infinity. So that's your domain. Again, any restricted values in your x's that you can't have, so that would be this vertical asymptote or that hole. Those are the x values you can't include. Now we need the y values. Start at negative infinity. What's the first y value we cannot have? Negative 2, the horizontal asymptote. Then we can't have the y value of the whole, so that is negative 7/5. They give that to us. So that is your domain and range. Simply, that's what they're looking for. We're okay with how we found that? We did that yesterday also. 2. What factors are guaranteed to be in the denominator of the equation of h of x? Give a reason for your answer. So denominator, which ones are in the bottom? Which factors?
2, x equals 3, and x equals negative 2.
So x equals negative 3 and 2, which would be the factors of x plus 3 and x minus 2. And we have to have an explanation. So why are those the ones that are in the bottom?
2 is a whole, and then negative 3 is a first class.
Exactly. So we're just going to state that they're both discontinuities. Both are discontinuities. That's why they're in the denominator. So nothing else in the denominator. Third, they want to know what values of x is your function h of x less than or equal to 0. Give a graphical reason for your answer. So graphically, when you're looking at your picture up there, where is it less than or equal to 0? Very good. That is exactly right. So you're going to go from negative infinity to negative 3. This is negative values here. So those are all included. Very good. Then you're at negative 1.5. Why is there a bracket? I agree, but why is it there? Yeah, it's less than or equal to. So right there is equal to. So use a bracket, negative 1.5, and then everything this direction to 2. And then we don't have a value at 2, so you have to skip over 2. That's why we have it right here as a union. And then from 2 to infinity. So the part that's not included is this piece up here. This is not less than or equal to 0, that part at the top. So graphically looking at it, when you're trying to find your answer, h of x is less than or equal to 0 when it would be on or below the x-axis. When it's on or below the x-axis, that is when it's less than or equal to 0. Very good. And the last portion at the bottom. It says it wants standard form. Find the equation of h of x. Give 2 graphical and algebraic connections that confirm that your standard form is correct. So again, we have found standard form. We did that yesterday. But first, you need to find your factored form, and then you can find your standard form. Now remember, some of them, this one may be one of those. Yesterday, when we were finding those, had a trick. Once you found the factored form and you tried to change it to standard form, you may had to multiply by something to get your answer to be correct. So double check your answers. What factors do I need on the bottom? factors do I need on the bottom?
X plus 3, X minus 2.
X plus 3, X minus 2. Those are the discontinuities. Very good. What factors do I need on the top? Rebecca?
I got 3x plus 2 and x minus, wait, not x, yeah, x minus 2, sorry.
Okay, I had X minus 2. What was your other one again?
I got like 3x plus 2 because the, oh wait, no, it'd be 2x plus 3.
Yeah, 2x plus 3. So we see that 0's at negative 1.5, which would be 3 over 2. So that would be x plus 3 over 2. But again, to get rid of that fraction, multiply it by 2. So that was that trick. This one on the top was x plus 3 over 2. But again, to get rid of that fraction, multiply both by 2. You get 2x plus 3 there. On the bottom, I got x squared plus x minus 6. What did you get on the top? What did you get on the top? Anybody? Multiply out the top? Go ahead, Marie.
Would it be 2x squared minus x minus 6?
Okay, so this is multiplied out what we have here. Let's check our answer now. The powers are even. So what kind of asymptote? Even power. What does that tell us about the asymptote? Okay, it is equally heavy. What does that mean, though? How do we find the asymptote if it's equally heavy? What was that, Emily?
Divide the
Leading coefficients, 2 over 1, so 2. Is our horizontal asymptote at 2? No, it's at negative 2. So before we change anything, let's check our constant terms. The constant terms are supposed to be the y-intercept. Negative 6 over negative 6, that's positive 1. Does it cross at positive 1? No. So we have some sign error. So what do you think we can do to this original factored form to correct our answer over here? We have a sign error. Rebecca?
You can multiply one of either the top or the bottom by negative 1.
Yeah, we'll just multiply the top by negative, and that would change all the signs on the top. That would make the first term a negative, the second term a positive, and the last term a positive. So really, that trick on the top, we didn't just have to multiply by a 2, we multiplied by a negative 2. Now let's check. We know our factors are still correct because those are all the ones we created from up above. Multiplied out, negative 2 over 1. Horizontal asymptote, negative 2. Correct? 6 over negative 6, negative 1, and it does cross at negative 1. So everything does check out now. The trick on that one, you had to multiply by negative 2. Any questions on that? We still need our explanations. We're not done yet. But that's the mathematical part, finding out the standard form. We're okay with that little trick we used? All right, so 2 things we need to state. And it's pretty much what we just talked about to confirm our answer. This is how you know that your standard form was correct. The ratio of the leading coefficients was negative 2 over 1. So horizontal asymptote is y equals negative 2. The ratio of the leading coefficients was negative 2 over 1, so the horizontal asymptote is y equals negative 2. Then the ratio of the constant terms is 6 over negative 6. So y-intercept of negative 1. So that's where we're going to stop for today. If you have any questions, I'll answer anything you may have. But that's where we're going to stop for today. We'll pick up there either tomorrow or Monday. I have to see how many people are going to be absent throughout all of my classes, and that'll determine what we're going to do tomorrow. So we'll pick up when everybody's back with this one.